Ever wondered how software systems are designed and structured? Well, it's a fascinating world where creativity meets logic, and it all starts with software design and architecture. These are crucial stages in the software development process that provide the blueprint for a system, defining its structure, components, interfaces, and data. They not only ensure that the system meets technical and operational requirements, but also pave the way for robust, scalable, and maintainable software systems. In this video, we'll delve into the depths of software design and architecture, exploring their purpose, levels, and approaches. We'll also touch on the tools used in the process and the considerations that guide architectural decisions. We'll conclude with an overview of the relationship between software design and architecture, highlighting their distinct scopes yet intertwined roles in the software development process. So, are you ready? Dive in to explore the fascinating world of software design and architecture. Understanding the blueprint of a software system begins with software design. Indeed, software design is the master plan that guides the development of a software system, bridging the gap between requirement analysis and coding. It provides a detailed specification of the software's structure, its components, interfaces, and data. In essence, it's like a roadmap that ensures everyone on the development team is navigating towards the same destination. Now, this roadmap operates on two distinct levels: the high-level design, HLD, and the low-level design, LLD. High-level design is like the bird's eye view of the system. It focuses on the system's architecture and its main components, outlining the relationship and interactions between various modules. Think of it as a city map, showing the main streets, landmarks, and the overall layout, but not necessarily every tiny alley or individual house. On the other hand, low-level design is the street view, providing granular detail of each module or component. It defines exactly how each component will function, its interfaces, and how it interacts with other components. Using our city map analogy, this would be akin to zooming in on a particular neighborhood, detailing each house, alleyway, and even the layout of individual rooms within houses. Both these levels of design are essential. High-level design gives you a comprehensive overview, ensuring all main components are in place and interact correctly. Low-level design, meanwhile, ensures each component is well-defined and optimized, functioning as intended within the larger system. Together, they create a detailed and organized structure for the software. Like a well-planned city, every component has its place, every interaction is accounted for, and the whole system works together seamlessly, efficiently, and effectively. These levels of design ensure a detailed and organized structure for the software. Different software projects require different approaches to design. That's the foundation of software design, as it adapts to the unique requirements of each project. Let's delve into three main approaches: procedural design, object-oriented design, and design patterns. Firstly, procedural design. This approach is based on structured programming. Think of it as a recipe. It focuses on procedures or functions that are executed in a specific order to achieve the desired result. It's like baking a cake, where you follow steps in a particular sequence. Procedural design is straightforward, making it a good fit for simple linear programs. Next up, object-oriented design. This approach turns the focus from procedures to objects. It's a bit like a factory production line. Each object has a specific role, like different machines in a factory, and they work together to create the final product. Object-oriented design utilizes classes and objects, emphasizing the principles of encapsulation, inheritance, and polymorphism. It's ideal for complex systems and promotes code reusability and modularity. Moving on to design patterns. These are not so much an approach, but common solutions to recurring design problems. They're like the blueprints architects use when designing buildings. Examples include creational patterns like singleton and factory, which deal with object creation mechanisms. Structural patterns like adapter and decorator focus on class and object composition, and behavioral patterns like observer and strategy deal with communication between objects. Design patterns offer proven solutions which can speed up the development process and improve code readability and reliability. Each approach has its strengths and weaknesses, and the choice often depends on the project's specific needs. A simple program might benefit from a procedural design, while a complex, scalable system might be better suited to an object-oriented design or a suitable mix of design patterns. In conclusion, The choice of design approach can significantly impact the software's functionality and efficiency. It's worth taking the time to choose the most suitable approach for your software project, ensuring it meets its requirements effectively and efficiently. Tools for software design help visualize and create the software's structure. To map out the software's layout, developers often turn to UML, or Unified Modeling Language diagrams. These diagrams encapsulate the software's components, their relationships, and their interactions in a single comprehensive visual. Another valuable tool is the flowchart. Flowcharts illustrate the flow of control in a system, showing the sequence of operations step by step. They are especially useful in procedural design, where the focus is on the sequence and execution of operations. Entity relationship or ER diagrams also play a crucial role in software design. These diagrams represent the relationships between different entities in a system, such as the data stored in a database. They are instrumental when dealing with complex systems with numerous data interactions. Remember, the goal of these tools is to create a clear, comprehensive blueprint of the software system. These tools aid in the clear and precise communication of the software's design. Software architecture is about making crucial decisions that shape the software. It's like designing the blueprint for a building, except the building is your software system, and the blueprint is a collection of high-level decisions that dictate how your software is structured and behaves. Think of software architecture as the big picture view of a software system. It's about making choices that are expensive to change once they're implemented. These decisions include selecting the right frameworks, platforms, and standards for your project, and determining how they all interact with each other. Now, let's talk about different architectural styles. These are essentially the themes of your software structure, each with its own pros and cons. First, we have the layered or N-tier architecture. This style divides the system into layers, each with a specific role. Imagine a cake with several layers: presentation, business logic, and data access. Each layer interacts only with the layer directly below it, keeping the system organized and manageable. Next up is the service-oriented architecture, or SOA. This style consists of services that communicate over a network through simple, interoperable communication. It's like having a team of specialists, each with their own expertise, working together to complete a project. Then, there's the microservices architecture. This style breaks down an application into a collection of small autonomous services. Think of it as a beehive where each bee has a specific role, and together, they make the hive thrive. Lastly, we have the event-driven architecture. This style is built around events that trigger and communicate between decoupled services. It's like a domino effect, where one action sets off a series of reactions. The choice of architecture style isn't a one-size-fits-all decision. It depends on several factors, including the nature of the software, the team's expertise, and the long-term goals of the project. And remember, the architecture style you choose can greatly impact the software's scalability, performance, and maintainability. Make sure to weigh your options carefully, because a well-thought-out software architecture can lead to robust and efficient software that stands the test of time. So that wraps up our discussion on software architecture's purpose and styles. In the next scene, we'll delve into the tools and considerations for software architecture. Until then, keep designing, keep architecting, and most importantly, keep learning. Selecting the right tools and considering key factors is crucial in software architecture. The tools used might include architecture description languages, or ADLs, which are programming languages specifically designed to assist in the architecture process. Then there are modeling tools, like Spark Systems Enterprise Architect and Archimate, which help visualize and manage complex information. We also have frameworks and libraries specific to each architecture, such as Spring for microservices. Now, beyond the tools, there are several considerations that need to be taken into account. These include scalability, which is the ability for your software to handle increased loads; maintainability, or how easily your software can be modified; performance, which relates to how well your software responds to user actions; security, focusing on protecting information and systems from threats; and cost, which encompasses both the initial development and ongoing maintenance costs. These tools and considerations aid in the development of robust and efficient software. Software design and architecture, though closely related, serve different scopes and details. Picture them like a house. The architecture is the overall blueprint, determining the high-level structure, the number of rooms, and the materials used. It addresses non-functional requirements like security and performance, much like how a house needs to be sturdy and secure. On the other hand, software design is more like the interior design of that house. It deals with the functional aspects of individual components within that structure, defining how each room will be used, the furniture placement, the color schemes. In the software world, this translates to things like modules, interfaces, and data. Understanding both is crucial for developing robust, scalable, and maintainable software systems. It's about making informed decisions early in the development process, which can reduce costs and improve software quality over its lifecycle. In the end, both software design and architecture play pivotal roles in shaping the software we use daily.